हेलो बच्चों, good morning to all. Today I came with a new topic, that is the work, energy and power. Yes, we have discussed the energy and kinetic energy. Also we got the formula. What is the kinetic energy formula? You have got Ke equal to half mv square. Okay. And now today we will discuss the work energy theorem. Yes, work energy theorem. This is the important questions. Okay, work energy theorem means you know that whenever we apply the force on the object, okay, and due to which it changes from initial to finals. From means one point to another point, the change from one to another, you know that whenever the object moves, okay, due to movements, the energy released, that is called the kinetic energy. Kinetic energy, it means it changes from initial to finals. So what is the difference between them, that you will find out. Is it clear? So we have questions, okay, the work energy theorems, and before it, and those who are new student, please subscribe my channels, okay, like and share after completing this class. Okay, now come to the points. We will first define what is the work energy theorems. You know that the work energy theorems, that means you can write it states that the amount of work done by the applied force on the object is equal to the change in its kinetic energy. Okay, change in its kinetic energy. It means suppose that we have a points and here one object is, okay, and which having mass m. M is the mass. Initially it is in rest, but whenever the force will apply here, so now suppose it starts with velocity u and it goes from A to B, okay, A to B, and having velocity v, okay, and suppose the s is the displacement covered by them. Now you know that whenever it will cover the displacement, suppose that s, okay, A to B, then what will be the work done? Here u, what is the u? You can write here, so let u equal to initial velocity, okay, very good. V equal to final velocity, s equal to displacement, m equal to mass of the object. Okay, so whenever we apply the force, then we know that when we apply the force on them, so the amount of work done, what will be the work done? If you will take amount of work done, that is the small amount, okay, you can also write a small, better, okay, a small amount of work done, what you will write? That means dw is equal to f dot ds. Very good, because s is the displacement, so any portions you will take, this is the ds. Okay, now whenever you will remove this vector sign, so you will write here dw is equal to f ds cos theta, and you know theta is equal to 0. Okay, on that case you will write dw is equal to f ds into 1. Why? Because cos 0 equal to 1. So dw equal to f ds you have. Okay, but you have formula force equal to f equal to ma. Okay, put this value. So dw equal to ma ds can be right. And also you have formula a is equal to dv by dt. Then or you can write dw equal to m dv by dt. This value we can substitute and ds is here. Now you can exchange their position. Okay, so dw equal to m ds by dt and here will be dv. Why? Because you know that ds by dt is equal to v. Okay, so you can write dw is equal to mv dv. Okay, now integrate this one. Now integrating it. If you will integrate, then you have formula w is equal to integration of dw, and this is the velocity. So you will take the limits. Here will be initial is u and this is the final. So you can write u to v. Can we write? Okay, so you can put here w is equal to this value integration of u to v, and we have mv dv, and m is a constant. No? Okay, so you can write m integration of u to v dv. Now integrate this one. So w is equal to m, and here will be what is the integration v dv integration v square and by 2, and u to v you can take half common here. So w is equal to half m, and here is v square and u to v. Can we write? Okay, very good. Because you know that the integration, if we have the v square by 2, you can take common here half, then only you have v square, and now you will write v. Okay, upper limit minus lower limit. Very good. So w is equal to half m, here will be v square minus u square, and w is equal to, you can multiply here. So here will be half m v square minus half m u square, multiply this one. Okay, so this is the formula that we got whenever, okay, we observe that the object starts to move with initial velocity u, and it covers the, okay, displacement s and having their final velocity v. So this is a very important formula. Okay students, I think that you should write this question, that's important. Okay, so you can capture these ones and you can write this. Okay students, okay, very good. Now suppose that related the formula, you can also if you have the questions, one questions I can give you related these ones. Okay, now see that suppose an object, suppose we have, okay, means calculate the work done by the object having mass 20 kg when the force is applied it displaced in the direction of force having initial velocity 10 meter per second, and it increases and become 15 meter per second. Okay, 15 meter per second. Then you will calculate the work done. So what is given here? U equal to 10 meter per second is given, V equal to 15 meter per second, and also you have M equal to what? 20 kg. You will calculate W is equal to question mark. You have formula W is equal to half mv square minus half m u square. Now put this value. So you will write here half m, that means this is the 20, v square means 15 square minus half into 20 into u square means 10 square. Can we write here? Okay, so here will be, you can cancel out this one 10 times. So here will be 10 into 15, 15 is 225. Okay, very good. 225 minus, again you can cancel out 10. So here will be 10 into 100. And now you will multiply. So 2250 minus 100 and one more 0 will here. Now you can subtract here. So here will be 0 and 5, 2, 1. So this will be the work done, and what is the unit of that? This is the joule. This is the joules. Means such type of questions you can solve. Okay, if the mass of object is given, if the suppose there is also mentions the initial and final velocity, then you can find out. But suppose that the object having mass is given and you have to calculate their displacements. Already we have discussed. Okay, we will try to give more questions. Okay, the next class we will discuss. Okay students, and till now those who have not subscribed, please subscribe my channels. And also there are so many questions I have solved. You can see the previous questions. I think that will be helpful for you. Okay, students, thank you.